This is fall 2015, the solution to problem number 18. We have a force that's being applied to two blocks that are pressing against each other, M1 and M2. And we are asked to understand the relationship between them. And so before we even get to the question, I'm just going to draw the free body diagrams. So M1 is going to experience the force applied to it. And it's also going to experience the normal force of M2 pushing against it. So I write this as the force on 1 by 2. And M2 is not in direct contact with the applied force. The only force it sees is the force of on 2 by 1. It's the normal force of mass 1 pushing against it. So this sees the force of mass 1 pushing against it. This sees the force of mass 2 pushing back against it. And the really important thing to point out is that these are a Newtonian pair. The force on 1 by 2 is equal and opposite to the force on 2 by 1. And so that's going to really help us rule out answers. In fact, answer for A, or the option A for for problem number 18, is that F by 1 on 2 is greater than F by 2 on 1. But we know that that's not the case. They have to be equal and opposite. Now, a net force is being applied to M1 plus M2. At the end of the day, those two blocks are sitting there, and now I'm pushing them. And they're going to be able to move together. There's no friction, there's no opposing forces, so they have to accelerate. And if they have to accelerate, then the condition on M is that there has to be a net force on M. And if there's a net force on M, that means that F applied minus F12 has to be greater than 0, which means that you cannot have F applied equals F12 because then you would have no acceleration, mass 1 would be stuck. Now, it is worth pointing out that there's sort of an extreme case in which the acceleration would be 0. If mass 2 was infinitely large, then the force applied from 1 to 2 would be equal to the force applied. We wouldn't be able to accelerate it because you can't accelerate an infinite mass. But anything that is finite, the F applied will be greater than F12. And the bigger M2 gets, the closer F12 gets to F applied, but F applied always has to be greater than F12 so that there will be some acceleration. And that gives us that the answer to question 18 is E. We know that F applied is greater than the force applied by 1 on 2, and the force applied by 1 on 2 is equal and opposite to the force applied by 2 on 1. So that is our answer.